All right, here we go. This is the second video for Unit 2.1, Real Numbers. We're looking at the second page of the notes here. Zoom in here. We got converting mixed numbers into fractions. All right, so to convert a mixed number into a fraction, all you need to do is multiply this 2 times 3. So you're going to multiply these two numbers, and then you're going to add this number. Okay, so this is 2 times 3, which is 6, plus 2, which is 8, and then you're going to put it over the same denominator. Okay, put it over 3. All right, so if you want to write that little note that you have to put it over the same denominator, go ahead and do that in your margins there. For negatives, this can get a little confusing if you try to multiply a negative and then add the 4. So just go ahead and just pretend it's not there. Just put the negative into your answer and then just pretend it's not there as you're actually doing the converting. All right, so we're going to multiply 3 times 5, and then we're going to add the 4. All right, so 3 times 5, that's 15. 15 plus 4 is 19. And then we put this all over the same denominator, which is 5. All right, so that is how we convert mixed numbers into fractions. And then if you wanted to convert these fractions into decimals, all you would have to do is divide the top by the bottom. So this would be 2.6667. I'm going to just round and call this 2.67. For 19 over 5, that's going to reduce or convert to negative 3.8. All right, so there's two ways to do that. Okay, moving on. Absolute value. Absolute value, I don't know why, but a lot of students struggle with absolute value. So we got a little definition we got to write down. If I can get this to work. Come on. Let's try it here. All right. Absolute value is just the distance between a number and 0 on the number line. All right. That's it. Now let's go ahead and make this a little bit smaller, a little less crooked. There we go. Pause the video if you need to. Write down that definition and let's really think about it. So the distance between a number and 0 on the number line. So the key here is distance, all right? So this is about distance, and distance can never be negative. So absolute value, you should write this down, is always positive. Because your distance can't be negative, all right? You can have negative numbers, but distance can't be negative, all right? And this is about distance from 0 on a number line. So if we have zeros here, we got 1, 2, 3, and we have negative 3, negative 2, negative 1. All right, so if we're talking about negative 3 and positive 3, they are both 3 units away from 0, okay? So if another way to say this is the absolute value of negative 3 is 3, and the absolute value of positive 3 is 3. Okay, because the distance for both of them is 3 units away, and distance cannot be negative. Okay, I hope I've made that clear. This is always something that students get a little bit mixed up with. A lot of people think it's just the opposite, but it's not. It's just always positive. Okay, always positive. All right, so let's take a look at some examples here. So simplify the absolute value expression. So what's the absolute value of negative 8? It's 8. It's just always positive. What's the absolute value of 9? It's 9. It's just positive. Absolute value of negative 2 3/4? Positive 2 3/4. Okay. Now sometimes you have to do a little bit of figuring beforehand. So we're going to do what's the absolute value? What is 12 minus 7? So these are grouping symbols, so you would have to solve inside them first, right? So 12 minus 7 is 5. And what's the absolute value of 5? Again, it's always positive. All right. Now this gets a little tricky because this negative is on the outside. So if we simplify in here, right, what's the absolute value of 5/3? Well, it is positive 5/3. Okay, but then this being outside of that, it just kind of drops down and then makes it positive. Okay, so there's a big difference there. Okay, all right, moving on. So on your test that you will take, there is but a majority of the test will be spent on tackling these types of problems. So these are a little bit labor intensive, but if you follow the right steps, I promise they're not as bad as they might look. So we have to order these, okay? And so I think the easiest thing to do is just to convert them into decimals. You could convert them into fractions, but sometimes that still might not be as easy to recognize with the eyes as converting them to decimals. Okay, so 3.6. All right, well, 3.6 is just 3.6. That's good. What's the absolute value of negative 3.2? Well, that's positive 3.2. Okay, and now we have 13 over 4. So all we need to do there is divide the numerator by the denominator. So 13 divided by 4 is 3.25. Okay, and the last one. So you could convert this out into an improper fraction by the method I mentioned. We could multiply here and then add that number. But what we could do is probably easier, just know that 3 is your whole number and then just divide the fraction part. 3 divided by 8 is 3.375. So this 3 3/8 as a decimal is 3.375. Okay. Now, once you have it like here, it should be pretty easy. And if you're not sure, like what's bigger, 3.2 or 3.25, if you just add zeros, it might help. Okay, well this one's 3.20, this is 3.25. So 3.25 is obviously a little bit bigger, right? All right, so yeah, if you want to go ahead and order them first, that would be fine. So 3.2 is the smallest, right? Looks like 3.25 would be the next. Then 3.6, or you could, if this one has 3 digits, so you could call this one 3.600, and this one's 3.375. So this one's clearly smaller than this one, right? We're going to put that next, and 3.6 as the biggest. Okay, now on the test, I don't have them converted into decimals. You have to convert them back into their original form. So what was 3.2? Okay, that was the absolute value of negative 3.2. All right, then next 3.25, that was our 13 over 4. So let's convert that back to our improper fraction. We're done with that one. Then we got 3.375, so that was 3 3/8. And the last one was just a decimal, so we can just put 3.6 there. All right, so there is your final answer. That is from least to greatest. All right. Okay, so we're going to solve this next one the same way. It's just slightly more tricky because it is negative numbers. Okay, but we're going to solve it the same way. We're going to convert everything to a decimal. Okay, so -1, that can just stay as -1. Negative 4 over 3. So just go ahead and divide 4 over 3. And just remember that it's negative. So we get 1.33. 33, it's repeating, so I'll just put the line over top. And negative 1.2, that's already as a decimal, so that's good. And this one here, so we just need to figure out what the square root of 7 is. So remember, we just hit our secondary function, and it's the x squared button. Is how we get that little square root symbol. All right. You're going to press enter, and it should spit out the same answer. It's just going to show you the square root of 7 again. Just a reminder, you want to hit the double arrow key that is in the bottom right hand corner right above the enter key. Okay, and hopefully when you do that, you get 2.64575131. But I'm going to just call this 2.65. We'll round it up here. Just remember the negative is out here in front, so once we've converted it, you have to remember this is still negative. Okay? All right, so now we just need to order it. Now the tricky part here is to remember that we're talking about negative numbers. So actually the biggest number negative is going to be the smaller one, right? So it's a little counterintuitive. You just kind of have to think about this as like debts. Think about owing money, right? It would be much, you would owe more to owe somebody $2.65. You just owed them $1, right? All right, so the smallest number here is negative 2.65. That's our only 2, right? So negative 2.65 is our smallest, okay? And then what would be next? All right, hopefully we're recognizing negative 1.33 is a little bit, another way to think about this would be like, think about it in terms of like, you know, negative numbers as like colder numbers in the winter, right? If it were negative 1.3 degrees out, that is colder than negative 1 degree, right? So negative 1.33 is smaller than negative 1.2 and negative 1. Okay, so now we've just got these two left. What is smaller, negative 1.2 or negative 1? Negative 1.2 is smaller because it's further left on this number line. Okay, and negative 1 is going to be the largest, actually, or the greatest. All right, so the next thing I need to do is transfer this back into the original form. So negative 2.65, well, that was our negative square root of 7. So let's convert that back. There's our smallest. Then we had negative 1.33. Well, that was negative 4 over 3. And then negative 2.1, or 1.2, sorry. And that was already a fraction or a decimal, so that's perfect as is. And negative 1 was just negative 1. So there we go. So I know it's a lot of steps, but if you take your time with it, I promise it will not be as bad as it might look at first. So just remember, first convert everything to a decimal, then line it up from least to greatest, and then convert it back to its original form. All right? Hopefully you guys do well with this. You guys can go ahead and for the rest of the week, just work on finishing the rest of these practice problems. I think there's 38 questions, which does seem like a lot, but a lot of these are just calculator work, and some of them take like almost no time at all. All right. So if you need help with this stuff, just reach out to me, email me, and we can do a Zoom meet or something like that. All right. See you guys.